12, and 13 can be done so that there is no phase shift. So in other words, you want to look at the graph and decide, does this look most like a sine function or does this look most like a cosine function?
Looks like
you want to say sine if the graph goes through the point 0, 0, or the midline and your y-axis. It hits that where those two intersect. You want to say cosine if the graph has a high point or a low point at the y-axis. So this one then looks like a cosine graph. So that means we're going to need a cosine bx plus c plus d and figure out what a, b, c, and d are.
You say sine if it goes through 0, 0?
If it goes through 0, 0, or the better way to put it is the midline and the y-axis, it goes through that intersection.
So it's either a sine function or a cosine function, period.
Right, because it's a sinusoidal. It tells you it's a sinusoidal curve, and that means it's either a sine graph or a cosine graph. You can write it as one or the other, or both. I mean, you can write them as both. Not at the same time,
but it's easier.
There's one way that's usually easier, and that's what we're aiming for here.
Okay.
Now, looking back at your original cosine graph, on the y-axis, was it at a high point or was it at a low point, the original cosine graph? At a high point. So what do I need to do in front of my function to make it a low point, to move that high point down?
Negative.
So I'm reflecting over the x-axis. So that means A must be negative. Now, what is A related to? Remember we said the absolute
amplitude.
Value of A was something.
Amplitude.
Amplitude. What's the amplitude of my graph? 2. The distance from what appears to be the midline to the highest point is 2. So the absolute value of A is 2. That means A must be
2. Negative 2.
Negative 2. Yes, Laura.
Does it say somewhere that it was reflected over the x-axis?
You have to tell from the graph that a standard cosine graph has a high point when it runs into the y-axis. The fact that this one has a low point means it had to have been reflected over the x-axis in order for that to happen.
I don't get it.
Look at your original cosine graph. We decided that this was most easily a cosine because the cosines are easier to do if they have a high point or a low point on them when it hits the y-axis. Yours, yes?
What's the equation of the original cosine graph?
Cosine of x.
Oh, okay. I don't know.
Oh, yeah, just cosine of x. So if you look at your standard cosine of x graph, it is up at where it runs into the y-axis. It's got a high point.
I don't know what that means.
Look at the graph. Do you have a copy of the graph? Do you have your calculator?
Yes.
Graph it on your calculator. So this, you should be looking for a place where it's got at highest points and it's heading back down. But that should be here at the y-axis on your graph on your calculator, where you graph cosine of x. You see that?
No, not yet, but I know what you mean now.
Okay. So now, since this one doesn't have that, instead it's got a low point, how do I get something to go from here to here?
Okay, I get
And
it.
the quick way to do that without shifting left-right is to reflect over the x-axis. So this one looks like it's the standard cosine but reflected over the x-axis, which can only be done by making the A negative. Okay?
Got it. Thank you.
So A is negative 2. B, what is B related to? The period. Remember that the period is equal to 2 pi divided by B. This is true for cosine, sine, secant, and cosecant, which we're going to get to in a minute. Can I tell from the graph what the period of this function is?
Yes.
Yes, how? What's the 3, 2 going to do for me? 3, 2, halfway, are you sure?
3, 2 gives
Yeah,
you...
I want to count from one to the other. The reason it gave me 3, 2 was to make it clear that that's supposed to be the point instead, you have to be given those high points, at least one of them, to say, look, this is really supposed to hit that, and so any of the others are supposed to. So you want to count from, can I count from a low point to a low point? Would that be okay? Good, because I can reach those. Low points are down here. From here to here, does it hit everything once? Goes from one low point all the way up, comes back down, and starts over.
Yeah.
So any pair of places where I can clearly see that, I can count how many spaces there are from one to the other. Now, my spaces are one apart, so this goes 1, 2, 3, 4, 5, 6. So the period of this function is 6. So that means 6 is equal to 2 pi divided by b. So 6b is equal to 2 pi. So that means b is equal to 2 pi over 6, or you can simplify that to be pi over 3. I decided this was a cosine function. And I've also said it was reflected over the x-axis. So is there a phase shift? In other words, is it moved left or right from anything? Nope. So that means C is 0. Midline. That's my D. Is the midline moved up or down? Nope. So my D is 0. That means for this function, f of x is going to be -2